Welcome everyone to this video lecture, Laplace Transform of Convolution of Two Function. I am Dr. H. Girija, Assistant Professor, Department of Mathematics, Sathyabama Institute of Science and Technology, deemed to be University, Chennai. In this video lecture, we are going to cover what is a convolution of two function, how convolution applied in different fields of engineering, and convolution theorem, and later we discuss about problems under convolution. So what is convolution of two function? How we define the convolution of two functions? F of t and g of t are the two separate functions. Then f of t star g of t is defined as f of t star g of t, that is convolution of the two function f of t star g of t is equal to integral over 0 to t f of u g of t minus u du. So the application, convolution has applications over probability, stochastics, acoustics, statistics, spectroscopy, signal and image processing and differential equations. The convolution of two signals consists of time reversing one of the signal, shifting it and multiplying it point with the second signal and integrating the product. That's why f of u g of t minus u du. In theorem, how to apply it? The time convolution property of the Laplace transform states that the Laplace transform of convolution of two signals in time domain is equivalent to the product of their respective Laplace transform. The visual representation. So the Laplace transform theorem, convolution theorem, Laplace transform of f of t star g of t is equal to f of s g of s. What is f of s? If L of f of t is equal to f of s, Laplace transform of a function g of t is equal to g of s. Then Laplace transform of convolution of two function is equal to product of their Laplace transforms. So the proof of the theorem, first we'll write down the convolution of two function, two signals, and then Laplace transform of any function is defined as L of f of t is equal to integral ranges over 0 to infinity e to the power minus st f of t dt. So that is also defined as capital F of s. So by applying in place of f of t now f of t star g of t, then this is reduced to L of f of t star g of t is equal to double integral 0 to infinity 0 to t e power minus st f of u g of t minus u du and dt. So now here u ranges over 0 to t and t ranges over 0 to infinity. Now by applying the change order of integration, we have to change the limits du dt to dt du. So these are the limits. For that first we have to find out the bounded region. So u is equal to 0 on the t axis, t is equal to 0 on u axis, and u is equal to t, the line, the bisector of the first quadrant, and t is equal to infinity, the imaginary line parallel to t on the u axis. Now we have to consider a strip parallel to t axis. Then t ranges from the lower edge of the strip touches the point t is equal to u to t is equal to infinity. And if you rotate the strip and fix it on the axis, u ranges from 0 to infinity. So by changing the order of the integration du dt to dt du, the new limits are t ranges from u to infinity and u ranges from 0 to infinity. So therefore convolution of two functions reduces to L of f of t star g of t is equal to integral ranges over 0 to infinity, integral ranges from u to infinity e power minus st f of u g of t minus u dt du. First we are going to integrate with respect to t by treating the other variable as constant. Therefore just by assigning t minus u as some other variable v. So by assigning t minus u is equal to v, differentiating both sides dt is equal to dv. Now we have the new set of limits from t u to infinity shifted to v ranges from 0 to infinity. Therefore, Laplace transform of convolution of two functions now reduces to integral ranges over 0 to infinity f of u. We didn't disturb that function, and inside wherever we have t, we have to rewritten in the form of t is equal to u plus v. So e power minus s times u plus v g of v dv du. Just writing as a product of two function. Since both limits are same, 0 to infinity, all are constant limits. So just by rewriting this as product of two functions, integral 0 to infinity e power minus su f of u du, integral 0 to infinity e power minus sv g of v dv. These two is nothing but Laplace transform of f of t, Laplace transform of g of t. So that's the theorem. L of Laplace transform of convolution of two function is nothing but product of their Laplace transform f of s into g of s. So by using this result, we'll apply for inverse Laplace transform. L inverse of f of s g of s is nothing but f of t star g of t. How to write down the value of f of t star g of t? Integral ranges over 0 to t f of u g of t minus u du, or in other manner integral 0 to t f of t minus u g of u du. So this we apply while doing problem to find the Laplace inverse of product of two functions. So by using this result, now we'll discuss some problems under convolution theorem. First problem, find L inverse of 1 by s plus 2 into s square plus 9. So here we have product of two function. One is 1 by s plus 2, another one is 1 by s square plus 9. So we're going to apply convolution theorem here. So what is here f of s? Capital F of s is the first function, 1 by s plus 2. So now if we apply the inverse, small f of t is nothing but L inverse of f of s, that is L inverse of 1 by s plus 2 is nothing but e power minus 2t. Similarly, the second function g of s is 1 by s square plus 9. Now by applying again inverse for that function, small g of t is equal to L inverse of capital G of s, that is nothing but L inverse of 1 by s square plus 9. So that is nothing but sin 3t. L of sin at formula, a by s square plus a square. So here the numerator constant is missing, therefore we will divide it with the 3. Therefore L inverse of 1 by s square plus 9 value is sin 3t by 3. Now we are going to apply these two results in this formula. In place of t you have to apply t minus u. In place of t we have to apply u. So now the given problem can be rewritten by using convolution theorem. Integral ranges over 0 to t e power minus 2 times t minus u sin 3u by 3 du. Hereafter we are going to evaluate. So for that here the variable is u, so no need we bother about the t. So just removing that value t outside, e power minus 2t by 3, and the integral ranges over 0 to t e power 2u sin 3u du. So by using this formula easily we will derive the result. Integral ranges over exponential into trigonometric function. So in the place of a and b, now we have to rewrite with the corresponding value. Then the given problem is reduced like this. Now we are going to apply the limits t under 0. Then it's reduced. Laplace inverse of 1 by s plus 2 s square plus 9 is 2 sin 3t minus 3 cos 3t plus 3 e power minus 2t by 39. Now we'll get to the next problem. Second problem, find L inverse of 1 s by s square plus a square into s square plus b square. So again it's possible for us to rewrite the given problem as L inverse of 1 by s square plus a square into s by s square plus b square, or s by s square plus a square into 1 by s square plus b square. Again we are going to apply the convolution theorem. So this is a theorem. L inverse of f of s into g of s equal to integral over 0 to t f of u g of t minus u du. So here the first function f of s is 1 by s square plus a square. By applying inverse, the corresponding function is sin at by a. Similarly, g of s is s by s square plus b square. Then L inverse is cos bt. So this can be rewritten as integral 0 to t sin au by u. By rewritten, first function is u, second function is t minus u. So here we are going to apply the formula. What is the product of sin into cos? So by applying 2 sin a cos b formula, sin of a plus b plus sin of a minus b. So just by rewritten a as here au, and in place of b, cos of bt minus bu. So we'll substitute it. Then this reduced like this, 1 by 2a integral over 0 to t sin of a minus b times u plus bt plus sin of a plus b times u minus bt integral over du. Okay, so we are integrating with respect to u. Therefore, integral of sinus minus cos. Therefore, minus cos of that value divided by a minus b, the coefficient of u. Similarly, minus cos of a plus b times u minus bt, and the coefficient of u is a plus b. Now we are going to apply the upper limit in place of u as t and then the lower limit 0. So if you apply the upper limit in place of u as t, at minus bt plus bt, so minus bt plus bt get cancelled, we will getting cos at. Similarly there itself at plus bt minus bt, so bt term get cancelled there, again we will get a cos at. Similarly now we are going to apply in place of u as 0, so we get cos bt and second half will get cos of minus bt. So cos of minus theta is cos theta only. So for lower limit we have to write minus of, so minus of minus plus. So we have 4 terms, we try to simplify this. So but here we have the denominator as a minus b, a plus b. So by combining this denominator, then this is reduced to a plus b, a minus b is nothing but a square minus b square. So by cross multiplying the coefficient is reduces to 2a times. Similarly there coefficient a minus b, a plus b, by cross multiplying we will get a 2a times. So 2a get cancelled, therefore the result, the answer, cos bt minus cos at by a square minus b square. Like this we will derive for convolution of any two function, exponential into trigonometric or trigonometric function. Easily we will find out the answer using Laplace transform by applying convolution theorem. So practice problems, L inverse of 1 by s plus a s plus b, L inverse of s square by s square plus a square, s square plus b square. So easily we will rewritten as s by s square plus a square into s by s square plus b square, and again we have to apply cos into cos formula. Again last one, 1 by s square plus a square, 1 by s square plus b square. We apply here sin a sin b formula. Thank you all. Hope you enjoyed the video. Thank you all.